Okay, let's move on now from adding and subtracting to multiplication. We've seen problems like this before. We take our 3 and multiply by 9. We get 5x minus 27. Right? Like terms? No, of course not. Right? If we remember what multiplication means, we're saying I have 5x minus 9 being added repeatedly. How many times? 3 times. So now I can combine like terms. 5x plus 5x plus 5x. Well, how many 5s is that? That's 3 5x's. And I have 9 plus another 9 plus another 9, all negative. So 3 9s makes 27, all negative. Right? When we distribute that 3, it's being distributed to both terms here. And we can distribute that as well for both of these expressions. Right? Use what you know about exponents to simplify these. Three times 5 is 15. X times x is x squared. This minus 9, I can either write it as a minus. 3 times 9 is 27. Here's my minus. Or I can think of that minus as a plus negative. There we go. Right? 3 times 5 is 15. Plus negative 27. Plus negative 27 is the same as minus 27 times an x. Right? Whether we keep the minus as a minus or whether we think of it as a negative, it's doing the same thing here. Right? Now the reason why we take a whole section on exponent rules before we get to polynomials is I want to be able to multiply this without a lot of confusion. I have the 3x to the 17th times 5x to the 4th. So 3 times 5 is still 15. Well, how many total x's do I have here? I have 17 x's being multiplied together times 4 more. 17 plus 4, 21. Right? I don't want to have to write out all 21 x's. I can just use that shortcut. 17 plus 4 is 21. And 3x to the 17th be multiplied by this term. 3 times 9 is still 27, still negative. 17, and then times one more x, that's an 18th x. So here are our answers. See if I can draw a straight line here. There we go. All right. Well, let's keep on multiplying. Oops. A little preview there. 23 times 12. This doesn't look like a polynomial. Right. Numbers are a little high to do in our head, so let's work it out. Okay. 2 times 3 is 6. 1 times 2 is 2. So 23 times 12 is 26. No? No, of course not. When we're multiplying, we don't just multiply like terms. Oops. When we look at an expression like this, I'm not just multiplying my x term by my x term and my constant term by my constant term. Right? That's what I did here. Multiply my 1s, multiply my 10s. That's not the whole picture. Right? We also need to do 2 times 20. So let's erase this. 2 times 2 is 4. 1 times 3 is really 10 times 3. That's 30. So a 3 in the tens place. 1 times 2 is not 1 times 2 is 2. It's not even 110 times 2 tens is 2 tens. It's 110 times 2 tens is 200. Right? Multiplying 10 times 10 times 2, 200. Right? Same thing here. It's not 2x times x is 2x. It's 2x times x is 2x squared. Then the 2x is multiplied by the other one. 2x times 2 is 4x. Let's just erase this here. Then this 3 isn't just multiplied by the 2. The 3 is multiplied by the x. And the 3 is multiplied by the 2. Go back to green for that one. So there's the 6 we had before, right? When we multiply, we take this term, multiply it by both of those terms. There's my 46. We take this term, multiply it by both of those terms. That's my 230. Then I add up my tens, combine like terms, I get that. I take my 2x, multiply it by both of these terms, 2x squared and 4x. Then I move to the next term here. Take my 3, multiply it by both of these terms, 3 times x, 3 times 2. Then if I have like terms, x and x are like terms, I add those up. And you get my answer. Now, some people like to add in the extra step. 2x is being multiplied by both of these terms. So I can write that as 2x times both of those. And then distribute just the 2x. Not 2. 2 times 2 is 4. And then I take the 3 and multiply it by both of those. Right? Personally, I think writing this step is an unnecessary time user. Drawing these little rainbows in, to me, helps me keep track of everything well enough, and I can jump straight to here, which is what I did. Right? It's your choice whether you write this or not. When we look at more complicated expressions, we still have the choice. As long as we're taking each of the terms in my first polynomial and multiplying them by each of the terms in my second polynomial, I'm all set. So just like with simplifying regular expressions where we don't have grouping symbols, we have to recognize the terms before we can simplify them and then combine them, right? We have to recognize how many terms we have in each of our factors here. So here I have a plus sign, so here's one term, here's another term, and then a minus sign, so here's my third term. Over here I'm starting with the fresh parentheses. In between parentheses that means times. So here's a term, not times, minus, so plus the opposite of this other term. And I really like writing my minuses as plus negatives when we're multiplying. So let's get started. My first term here is 2x to the 5th. I'm going to distribute that to both of those. So 2x to the 5th times 5x and 2x to the 5th times negative 6. Then I move on to my next one. 3x squared, right? That's the next term over. 3x squared times each of these. Then I move on to my last one here. 7 is the last term here, but it's minus 7, so it's really negative 7 times 5x. And negative 7 times negative 6. I have 3 by 2, so I have 2, 4, 6 terms. My final answer might not have 6 terms, but once I've shown all of those multiplications, I'm doing 6 multiplications. Then we can simplify. So 2 times 5 is 10, times 5x's, here's one more, so times 6x's altogether. Then here, 2 times 6 is 12, and I don't have any more x's, so I just have x to the 5th. Now I've got 3 times 5 is 15, x squared times another x, that's x to the 3rd power. Then I have 3x squared times negative 6, so 3 times 6 is 18. Negative, right, because I have a single negative here, x squared. Then I have negative 7 times 5, that's negative 35 with a single x. Then I have negative 7 times negative 6. The reverse of a negative is positive, so I get positive 42. So I have 6 terms here. Now I'm going to look for potential like terms. So here's a 6th degree. No, no, no. Okay, that's the only 6th degree. 5th. No, 3, 2, 1, 0. Okay, it's already in standard form. Now, if I'm counting down, 6, 5, 4, 3, 2, 1, 0, right? A constant term is really the same as x to the 0. I don't have to write 0x to the 4th here. I'm not going to write 10x to the 6th minus 12x to the 5th plus 0x to the 4th plus 15x cubed minus 18x squared minus 35x plus 42. That's not considered simplified. I can perform this operation. 0x times x to the 4th is 0. But it's still helpful to know that it's there. When you get to doing long division, you will have to put this in. You will have to recognize that there's a 0 in the x to the 4th spot. Right? But for now, we'll just write our answer. More simplified than this plus negative is not simplified. But it happened to be in the proper order. And that will often happen, because most of the time your polynomials are coming from whatever application. They're going to be written in standard form by themselves, right? So highest degree, next highest, a little bit lower. Among these two, 1 is higher than 0. So this is the higher degree term out of those two. Now if this one was x to the 7th, the way I distribute it here, I might have to do some shuffling at the end. But that's not the case for these particular numbers. I can draw a straight line, I promise. There we go. So let's look at one more problem here. Why don't you try this one on your own? Go ahead and simplify this one.